I'm here with Margaret Lewis. Margaret, I know that you and your family were horrifically affected by one of these all too common flame jetting incidents. I know that even though 20 months have passed, you're all still struggling with the severe physical and psychological impact. I was there with you outside the ICU, and I'm here with you now, because I know how hard facing down these issues can be. I also know that this makes you the person best able to explain why it's not your turn to burn.
Thank you. I appreciate your help. I couldn't get through this without a girlfriend. Yeah, as far as it goes, just being invited over here and said, hey, let's figure this out together is great. I'm trying to walk people through this because I understand that at first the science can seem hard if you haven't been around what happens. But once somebody walks you through it, it's really becomes straightforward. And please know, I'm a common sense mom. I don't have a science background, I don't have a medical background, I don't have any of this, but when you get thrust into a situation like this, you do learn. So in general, what happens with these types of situations is any type of commonly used household or flammable type liquids have a tendency when they get down somewhere between a third and a quarter full is when they're the most at risk. So just keep that in mind. What will happen is when you tip the bottle, you'll now have an air and liquid mixture where you get the right vapor concentration. Anything like an open flame is an ignition source. And what can happen is the open flame will follow the vapor trail back to the bottle. It's either a flashback, some people call it jetting, vapor explosion. All of the same thing is really what's occurring. But it's about having that unfortunate air mixture. And next thing you know, what will happen is, this is some different household products. Like here's gasoline over here, ethanol, we've got kerosene, and then there's also things like charcoal fluid. So please know that all of these are known for their flash points. When you get into this type of a range, this is where the mixture is such that it's flammable. It's like a flash point. Some products, like an ethanol, these things can be right at room temperature. They're flammable. They're ready to detonate. So this is sometimes, as you'll see in the science world, literally that's what it's referred to as. So right here in this range, that's actually a bomb. So as far as it goes, please keep in mind that some products, like a gasoline, you're going to have to wait until it either changes the richness. So gas, you have to evaporate some of it in order for it to get down into the flammable range. So that's why it's the age type of a gas. Charcoal, lighter, and stuff like that, you have to heat in order for the concentration to rise. So some things are going to be straight off the shelf, very, very unsafe. Others, it has to do with how it's used and how long it's been around. When it comes to what all this is known in the science world, this is called deflagration or detonation arrestors that are used. But when the product can flash back, it detonates like a bomb. So now you understand where the term detonation comes from. When it comes to our approach to this stuff, what we did is, our family started to realize the more we talked to people and tried to understand what happened to our own situation, we came across so many of these. It's a lot more commonly occurring than we actually ever would have considered. So in residential situations, fireplaces, barbecues, tiki torches, fire pits, campfires, bonfires, all these different situations have had this type of flashback jetting or else even a vapor explosion. But unfortunately, it's also happening in educational settings. We know of a case of Discovery Museum, little kids watching an exhibit, science classes in high schools and middle schools all over the country we're hearing about, we're reading about, we're coming across. Laboratories, whether it's a home lab, a professional lab, a PhD student in a university, we're finding out that there is lab experiments are happening. So even people with knowledge, even people with training and safety equipment, the same event is happening. Commercially, in a bar or restaurant, this can happen. We unfortunately have come across some of those examples. Industrial, flame arrestors have been known and used for a couple hundred years. So since they require it, and that's what OSHA standard is, we're using them as a benchmark for why this needs to be offered in all sorts of residential, educational, academic, and everyday uses. Heart-wrenching, we've met first responders firsthand. You know, our family knows people that have been injured on line of duty. They're there to protect us, keep us safe. Unfortunately, they're getting caught by these same catastrophes. Here's some examples of what I mean by why it overwhelmed our family. And Tracy, I just want to say thank you for your help today with this, because you understand what we go through. This is just part of us grabbing some things out of the news, and I'm trying to let you see for yourselves. And you know, you can see all these different examples that are occurring. Their homes, their science classes, these are labs, high schools, whether it's happening with you know, adults and principals, or whether it's happening in the U.S., whether it's happening, you know, in Canada. We're coming across those. These examples are pretty much all U.S., but please know it happens all over the globe. This isn't unique to any type of industrial nations. But what's happening that's heart-wrenching is the frequency, the repeatedness of it. It's no longer a freak accident when it's repeatable and it keeps happening over and over again. You know, home labs, I don't really care how somebody gets injured. I'm a mom. If their child is in a burn unit, as far as I'm concerned, that's the same as my child. So how it happened isn't really something I want to wrap my head around. I'm more about how do we prevent this. When I'm looking at some of these things, I'm really shocked to find how well known all of this is and how common it is. And the most heart-wrenching, gut-awful part of this is we can stop it. This isn't hard, this isn't expensive, this is proven, this is known. I will just take you through a couple of fun facts here. First of all, flame arrestors have been around and in use and known for over 200 years. They started back in coal mines in order to keep miners with a candle from getting burned up as they went down mine shafts. So if we have heard about them for that long and they came up with patents and things over time, you know, a couple hundred years ago, you didn't patent something for profit. Safety was the priority, and that was the social norm at the time. So it's good to know that we don't have to go up against patent infringement, but I'm trying to help you see just how many of these incidents have actually occurred. When it comes to what I mean by a flame arrestor, let me try to move over to that. Here's an example of one of the ones I think is a best in class. I actually really appreciate finding out that sometimes there are places where flame arrestors have been adapted, and that's what we want to have repeated. So here's one on a liquor. There's also ones that I've come across that I'm very impressed by. Let me use this example. This is charcoal lighter cap. I want to show you why, if you come across one in your shed and you've got one hole, don't use it. You want to know that these 3-hole ones, which is like this is safe. These squeeze bottles, you know, how hard is it for a manufacturer to make the difference between 1 hole and 3 holes? We know with injection molding, they can do it. And thankfully, there are products out there that now have those on it. One of the things that we want to do is talk about what these products need. So I want to make it super straightforward. When it comes to this, you know, we just did for demonstration purposes, take a look at these, and I'm just going to show you that when you open this and you see this does not have a flame arrestor, and you think to yourself, you know, why not? How hard would it be for them to find something like a spice bottle? Just take a little screening or something and go ahead and make something. So this is just our own example of how simple these are. You know, certainly there's a whole range of flame arrestors that they can design, and they're smarter than us. But I merely wanted to use this as a way of saying, this is a solvable problem. If we work together, we know that we can bring about this change, and it is time. You know, I am heartsick thinking about how many mothers and fathers and loved ones have ended up having to walk these same hallowed hallways that I've been down. And I don't sleep well at night. I don't feel good about what I've been through. I would hate for anybody else to have to experience it. And I think we can stop it. It is time. And if we speak together, we pull together, we can solve this. So I am frankly asking for everybody to help get behind this so we can get manufacturers to give us consumers a better, safer solution. And we don't have to keep going through this problem over and over again. So please get involved.